So last week, a former colleague of mine called me up. He had just read my blog, Beyond the Hype, and he wanted to build his first AI agent. He asked me two simple questions. One, what tooling should I use? And number two, what would be a meaningful use case that would actually solve a real problem? It got me thinking. Everyone's talking about agents, but where are the real examples you can actually build and use? I want to share with you exactly what I showed him, using the agent building stack you see on the right. The complete Claude platform for agent development and intelligence, MCP for seamless connections, and Snowflake for enterprise-grade analytics. Let's get started. So what's the real problem that we're going to solve? Even when you have all your health data in one place, you still can't do anything useful with it. So let me explain. I have all my healthcare providers linked to Apple Health. And if you don't, you're seriously missing out on having a single place for all your health details. Now here's my Dooley healthcare provider linked to Apple Health. This integration gives Apple Health access to my complete medical history, lab results, medications, vital signs, immunizations, everything. And here's what that looks like in Apple Health. This is incredibly rich data, 12 years of health history across 3 different healthcare providers. But here's the problem. I can see my health data, but I can't do anything meaningful with them. Want to see which labs are abnormal? Can't easily do that. Want to track cholesterol trends over time? Can't figure that out either. Want to correlate medication changes with health outcomes? Forget about it. Apple Health is a data graveyard. All this valuable health information just sitting there, unusable for any real analysis. That is our use case. How do we solve it? First, we'll export my entire Apple Health data as a PDF. 12 years of data, 8 categories of health information across 3 providers. This creates a 200+ page document that's completely unstructured. We're going to transform this corpus of health information into something actually useful. A conversational health intelligence system that can answer complex questions about my health history with 100% accuracy. Let's see how. The answer is a multi-agent system where each agent has a specialized role. Now, the first member of our multi-agent system is the Health Data Extractor agent. It takes our 200+ page document, extracts data using Cloud Opus 4, and organizes everything by clinical type and year to stay within context limits. The second team member is the Health Analyst Agent. It loads this extracted data into Snowflake through our custom MCP server, creating analysis views and semantic models. Now, when you ask a health question, here's what happens. Number 1, the Health Analyst Agent pre-processes your requests and coordinates calls between different tools. Number 2, it uses Cortex Analyst, Snowflake's own agent that handles natural language to SQL conversion, to convert your question into precise SQL. And number 3, the Health Analyst Agent then takes that SQL, executes the query, and processes the result to generate analysis and rich visualization. Now, let's build this multi-agent system with our agent builder tool, Claude Desktop. This is our agent builder. What makes Claude Desktop a powerful agent IDE is that each project serves as an agent with its own LLM, instructions, knowledge base, and now tools with the recent MCP support. Let's create our first agent. Let's give it a name, Health Data Extractor Agent, and a brief description. Perfect. In Claude Desktop, the project is our agent, complete with its own personality, instructions, specialized knowledge, and tools. But first, let's assign the agent's intelligence engine. Here, I'm selecting Claude Opus 4. This latest model has significant improvements in document extraction and complex reasoning. Now, I'm uploading the agent instructions. These contain detailed extraction protocols, zero tolerance for errors, character for character precision, and complete validation workflows. I'm also uploading 2 critical components to the agent's knowledge base. First, our 200+ page Apple Health that we've exported, and these JSON extraction schemas. These schemas are the foundation for accurate extraction. Let's take a peek at the lab results extraction schema. You can see it defines the exact structure. For example, test name, test value, reference range, plus extraction rules for data conversions and validations. Schema-based extraction minimizes the hallucination and ensures high accuracy. Okay, so let's ask the agent what it can do. Perfect. It understands its mission. Transform unstructured health documents into analytics-ready data with complete accuracy. Let's start with the extraction of lab results. Note that Claude has created a JSON code artifact for the first year, 2025. And we can see the streaming results going into the JSON code artifact on the right. This is a critical optimization strategy. Displaying the extraction results directly would cause errors with large data sets, which I personally ran into. But using code artifacts handles that volume seamlessly. Notice also it's creating separate artifacts for each year. This creation of a code artifact for each year is yet another effective chunking strategy that keeps us within the context limits while making the data queryable. Okay, in just a few minutes, the agent has extracted almost over 1,200 lab results spanning 13 years. Now, we can download these JSON extraction files locally, which will be used by our health analyst agent. Okay, so now let's extract the remaining data types. Extract my clinical vitals, extract my medications, extract my clinical data. In under 3 minutes, we've transformed 12 years of scattered health data into perfectly organized JSON files. Every extraction verified against the source document. Now that we have our structured foundation, let's build our second agent, the Health Analyst Agent. Again, in Claude Desktop, each project becomes a specialized agent with its unique capabilities. I'll configure this with the same Claude model, Opus 4, but now I'm uploading different agent instructions. These focus on data ingestion, Snowflake integration, and health analytics. I'm also uploading visualization guidelines to the agent's knowledge that will guide the agent in creating compelling interactive charts that we'll see shortly. But here's what makes this agent special: the tools. Out of the box, Claude Desktop provides standard tools like web search and email. But below, we see something powerful: MCP servers. Model Context Protocol, or MCP, lets us connect Claude to any system or database. I've configured 2 MCP servers here. First, the Anthropic File System MCP. This gives our agent access to read the extraction files we just created. Second, our custom Snowflake MCP server. This is the magic. I built this to give Claude 2 specialized tools. One for importing health data into Snowflake's enterprise data platform, and another for executing natural language health queries through the Cortex Analyst endpoint. Now, let me ask what the agent can do. Perfect. It understands its dual mission: import health data into Snowflake, then enable conversational analytics. Now, I'll give it the location where our extracted files are stored. Using the file system MCP, it's scanning the directory and cataloging all our extraction files: lab results, vitals, medications, clinical data, everything we created with our first agent. Now the real magic happens. It's loading everything into Snowflake, creating database tables, establishing relationships between different data types, and building semantic models that enable Cortex analysts to effectively convert natural language queries into precise SQL. Notice on the right panel, Claude is now analyzing the import results from the Snowflake tool call and creating a React code artifact. This is Claude's powerful code generation capability at work. It's building an interactive dashboard based on the actual data metrics returned from Snowflake. The React code artifact is now executing, and on the right panel, we see a comprehensive health dashboard rendered as a live web application. This interactive visualization shows our complete health landscape, over 2,400 records across 13 years, data distribution across 4 categories, and even year-over-year analysis of the various health metrics. Notice that spike in 2021? Well, that's when COVID health monitoring intensified. And 2017, that's when I had back surgery. You can see the medication surge. Now on the left, it's created structured data views and a health query guide. These components enable sophisticated health analytics through natural language. So let's ask our first question regarding cholesterol trends over the last decade. Notice something important. While I only mentioned cholesterol and triglycerides, the agent enhanced my request to include all key cholesterol metrics, total cholesterol, LDL, and HDL. This demonstrates the agent's intelligence in not just post-processing analytics, but pre-processing the request to provide comprehensive answers. The agent calls the Execute Health Query tool, coordinates with Cortex analysts to generate the SQL, and returns results for visualization. The visualization reveals an interesting trend story with triglycerides. Back in December 2013, my triglycerides were dangerously high at over 400. Following that trend line across the decade, we see a steady decrease year over year. But then a concerning recent spike back up to 153 in 2025. This raises 2 questions. 1, what caused the decade-long decrease? And number 2, what caused the recent spike? Let's examine the medication patterns to solve our triglycerides mystery. The agent is pulling medication data and matching it with cholesterol trends over time. I can expand that tool call and we can see the generated SQL from the agent. This gives us a good opportunity to see what's happening behind the scenes in Snowflake Cortex Analyst. Here in the Cortex Analyst monitoring view, we can see the exact request from our agent and the SQL it generated. Look at this comprehensive query. It's joining medication tables and filtering for statins, fibrates, and medications prescribed for cholesterol or cardiovascular health. This thoroughness is what guarantees our results are accurate and reliable. Back to our dashboard, this visualization reveals the answer to our decade-long decrease. The steady improvement from 2013 to 2021 aligns with consistent statin therapy, particularly when optimized to 20 milligrams during 2020 to 2021. But here's the intriguing part. The statin dose decreased from 20 back to 5 over the last 4 years. However, this doesn't fully explain the recent spike since earlier years on 5mg showed stable numbers. We need more information. Let's examine the recent abnormal lab results. Now we're drilling into recent lab work to find clues about our triglyceride spike. Here's a crucial piece of our puzzle. From 46 tests in April 2025, we see 2 abnormal results. An A1C at 6.1%, which is pre-diabetic range, and elevated kidney markers. Plus those borderline results, triglycerides that we saw earlier at 153 and HDL at 33. The agent identifies this as a metabolic syndrome indicators, pre-diabetic blood sugar, low HDL, and elevated triglycerides. This suggests our triglycerides mystery might be connected to blood sugar control. Let's examine how A1C, diabetes medication, and weight have changed together over time to solve this puzzle. Now we're correlating 3 different data sources: A1C labs, metformin dosing, and weight measurements across multiple years. Notice something remarkable. Claude Opus 4 breaks this complex question into strategic steps with multiple tool calls. First, metformin prescription history, then A1C results over time, and finally, weight measurements for correlation analysis. This reasoning loop showcases the advanced cognitive capabilities of Claude Opus 4. Here's our smoking gun. The timeline shows the complete story. Metformin worked initially, achieving the best A1C of 5.7% in February 2023, when weight dropped to 198 pounds. But then the weight gain overwhelmed the medication effect. The 27-pound gain from 2023 to 2025 directly correlates with A1C rising back to 6.1%. Interestingly, each 10 pounds adding 0.2% to A1C. This explains our triglyceride mystery. It's not just about the statin dosing, it's about the weight-driven metabolic decline. Ha! Look at that. And Claude gets the irony. Using AI to discover that working at an AI startup caused my health problems. The good news? I resigned a few weeks ago, so my triglycerides should be improving soon. Health mystery solved, career move made, and real-world AI agent building demonstrated, complete with the irony that makes it all genuinely human.